Okay, welcome everyone to this series of video lectures on ProtaStructures design software. Okay, so this lectures is going to be a series of structural design of both building and non-building structures using the ProtaStructure software. Okay, as we might know, ProtaStructure software is a modern software that is used for both concrete and steel building structure design. It has a lot of features. It has a lot of tools that makes the job easy for structural engineers or civil engineers alike. Okay, so in this first video, I'm going to be introducing you to ProtaStructure Interface. I'm going to be showing you around the tools, the commands, and what they are used for. And then before we begin into designing real life project proper. Okay, so when you have installed ProtaStructure software initially or in the beginning, there are three softwares that is going to be installed in your computer at the same time. Okay, these three softwares are the ProtaStructure software, which you can see here, then the ProtaDetail software, which you can see here, and the ProtaSteel software, which you can see here. Okay, so these three softwares are combined together into one. Okay, but the main software itself is the ProtaStructure software. That is this one with the red icon. So I'm going to open it right away so that I can show you around within some few minutes and show you the tools and commands that is being used in ProtaStructure software. So I'm going to open the software right away. By the way, my name is Engineer Prosper and I do structural and architectural designs as well using ProtaStructure software, using Orion, and then using Revit and AutoCAD as well. So this software has been very helpful since 2015 when I started using them. In fact, it has made my work very fast and easier. Okay, so I believe if you're into structural design or architectural design or whatever, softwares are very good for you. Gone are the days when we still do manual designs and with paper and pencil, and then we do our calculations. These days are actually gone, so people actually need fast work and efficient work as well. So that is why softwares are very useful for everyone that is into the construction industry. Okay, so when you open ProtaStructure for the first time, this is what you are going to see, excluding the recent projects here. So whenever you do a project and save it, it is going to be saved here. Okay, so these are the news from ProtaStructures. Whenever there's an update or there's something that came up, it's going to be shown here. Okay, it's going to be shown here. Okay, so recent projects you do are stored here, but when you install ProtaStructures for the first time, you're not going to see anything here. So what you simply do, there are two options. Is either you open an existing project if you have done a project before, or you create a new project. So for the sake of this video, I'm going to create a new project and I'm going to show us what we have. So project code simply means the name of the project or the title of the project. Let's assume you are designing a 5-bedroom apartment. You can see that I am using my dash on the keyboard to separate the words. This is because the space command doesn't work in ProtaStructure, so we use the dash command to separate our words. So we have 5-bedroom apartment. So now ProtaStructures uses a lot of design codes. You know, for structural design, there are different codes that is being used according to the country. Okay, you have the Brazilian code, you have the Hong Kong code, you have the Indonesian code, the Malaysian code, Singaporean code. So there are a lot of codes, but the code we use mostly in Africa is called the British code or the UK code. That is BS8110. So that is what we use mostly in Africa. So I'm going to select the UK code and I'm going to click on OK. So it is going to open the interface that we need to begin our project, and you're going to see how it looks. Okay, so when it opens initially, it's still loading. So when the software opens initially, you're going to see your interface right here, and then you're going to see several other commands on the top and on the side. Okay, I'm going to briefly explain what all these commands mean and how you can be able to use some of them. Of course, in the course of the project, we are going to be using a lot of them. We're going to be using a lot of them. Okay, so here you have your interface, your drawing interface. You can call it your drawing interface. Okay, so you can see your grids. This is the origin, meaning that this is where the sheet begins from. Okay, you call it the origin. You have your y-axis at the vertical, and you have your x-axis at the horizontal. Okay, so when you are beginning a project, this is where everything will be. Everything is going to be within this particular boundary. Okay, now at the top, if you look at the top, you can see that we have different tabs. Okay, we have the building setout tab, we have the modeling tab, we have the loading tab, the review tab, analysis tab, design, drawings and reports, BIM. BIM simply means building information modeling. Okay, and then you have the display tab, reviews, and your help tab. Okay, so these tabs, under each tab will have different commands or tools that helps us make our drawing or make our design. Okay, so under the building setup plan, we'll have several tools, several commands that helps us to save. This is the save. You can also save as something. If you want to save your project as a different name, you can do that here. You can also open a new project from here or create a new project from here as well. Why this save thumbnail simply means if you want to save a screenshot of the screen of your drawing, you can usually use this. While you can close project from here. Now you can merge two different models. Okay, let's assume that you have your models are in different maybe AutoCAD sheets. You can actually merge them here. Or if you have a model already in ProtaStructures and you want to merge another model into it, you can actually do that with this command here. You can also link model together. Okay, so you can actually import your drawings from different other sources like your AutoCAD, like I mentioned earlier. In case your drawing is in AutoCAD format, you can actually use this DXF import to import your AutoCAD drawing from AutoCAD into ProtaStructures before you can make your analysis and design. You can also use this command to import from Revit. Okay, from Revit. Of course, you know Revit is an architectural software. So let's assume that you have your architectural drawing in Revit format, okay, or in RVT format. Okay, just like AutoCAD is being saved as DWG or DXF, Revit drawings are saved as RVT. Okay, so if you have your drawings in Revit format, you can actually import them from here. You can actually also import reference drawings from other sources as well. You can also change your materials. This is settings, this is a load library. Okay, so this is where you actually get to see additional loads that you can apply on the building apart from the default loads. By the time we go into the training proper, I'm going to explain what are the different types of loads that is being added on the structure. You have your dead load, you have your live load, you have your wind load, and also you have additional loads that you can apply. Also, you have your stories. You can actually create stories. Let's assume that you have multi-story building. You can actually create them. You can edit the stories, you can remove the stories, you can delete, you can generate the stories. So there are many things you can do with this. So let's now move on to the modeling tab. Under the modeling tab, this is where you actually come to model the structure, assuming you are modeling the structure in ProtaStructure itself. Like I said earlier, you can either import your model from AutoCAD or from Revit into ProtaStructure, or you can model the drawing in ProtaStructure itself. Okay, so if you want to import, you either use this DXF import, Revit import, or external reference drawing. But if you want to model the drawing in ProtaStructures itself, then you come to this modeling tab and either use your grid or your orthogonal axis generator. Okay, this grid helps you create the grids one by one, and then you can model it as you wish, while this orthogonal axis generator helps you create the grids automatically. Okay, grids and axes are the same thing, so you can use them interchangeably. Okay, so orthogonal axis generator helps you create the axis automatically. Okay, if you have all the axes already. So while here you can actually draw polyline, circle, arc, rectangle. So we're going to be making use of all these tools in the coming videos. Okay, so we have the building structural elements right here. We have the columns, we have the shear wall or the concrete wall. Okay, this is not block work. You have to take note of that. It's not block work, it is concrete wall or reinforced concrete wall. We have your beams, you have your slabs, you have your ribbed slabs. Ribbed slab is simply a slab that is connected to beams rigidly. Okay, so you can see some buildings that have large spans but no intermediate columns. So ribbed slab are actually recommended for this kind of slab. So you have very large span of slabs, but you don't want any column in between. So you can use a grid form of beams to carry the slab. Okay, here we have slab strip. This is simply a tool that helps us bring out the reinforcement in a slab. Okay, so we are going to be using these tools in the coming video. So we have slab openings. Let's assume that you have a building and you have a hole in the slab. Let's say you're designing a duplex, this modern kind of duplex in which the parlor or the living room is open. Okay, and then you can view from the first floor down into the living room. Let's assume you are designing such kind of things. So you can actually cut the opening of the slab with this tool right here. Okay, so you can also insert slabs automatically. I'm going to tell us what this means in the coming videos. Insert slabs automatically. Okay, so there are different types of slab based on their support. Okay, based on their support. So ProtaStructures actually helps you insert the slabs based on their types and then based on their support. Okay, so while here you can actually set slab types automatically. So I'm going to explain what this means. Also, so you have wall groups. This is a block work. You can actually add block works on your beams. Of course, block works are known as additional loads on the beams, so you can actually add a block work on the beams. Here you can merge your vertical members, you can separate mesh members that you have meshed before. You can actually separate them. You can have your steel members, your support type. Okay, there are different types of supports. You have the fixed supports, you have the hinge support, you have the free support also. So there are different types of them of supports. Okay, so I'm going to be explaining in detail both the theory and how you can apply these things in ProtaStructures. You know, there are some basic theory or basic principles you need to understand to be able to use the software effectively. So I'm going to be explaining such things as we go. So floor plan section, you can actually cut a section of your slab. Let's assume that you have designed the slab, you have brought out the reinforcement. You can actually cut the vertical or the horizontal section using this tool right here. This is plane definition. If you want to move your slab to another plane, let's assume that your slab is not horizontal, your slab is inclined. So you can actually set the inclination using this tool right here. So let's move over to loading. This is where you actually get to load your structure. You have different types of load cases here. Okay, you can see your load combination, load cases and combinations. Now if you are familiar with manual design, you understand that there are different load cases that we actually use for our design, and we design based on the maximum load case. Okay, like I mentioned earlier, we have dead load, we have wind load. Then if your building is very high, you are supposed to have wind load as well. So now there are different load combinations because we don't actually join these three load cases together just like that. According to British code, there are different load combinations that will be tested. Okay, so anyone that is higher is what the software is going to use to perform the analysis. This is because of safety. Okay, this is because of safety, because we need to use the maximum load case to actually design the structure, the maximum expected load case that should be come on the building in the future. Okay, now if you have earthquake in the area you are designing the building structure, let's assume you are designing the structure in Asia, okay, where you have earthquakes, frequent earthquakes, you actually have to take that into consideration because earthquakes are another form of loading. We call it dynamic loading. Okay, so you have to take that into consideration. But fortunately, in Africa, we don't actually experience earthquakes, so we don't do earthquake loading. Okay, so we have wind load here as well. Okay, now if your structure is above 3 stories, you have to apply wind load on it. Okay, because the higher you go, the higher the wind load that will be affecting the structure. So if your structure is more than 3 stories, you have to apply wind load on it. Okay, so you also have non-structural component loads. These are loads that are not structural, not structural components of load. I'm going to explain this in the coming video. So we have partition walls, we have slab additional loads like the loads from your tilings, the load from any other thing that is not part of the building or that will be incorporated into the building. You can actually apply them here. This is also the tool you use to apply load when you have a water tank above your building. You know, there are some buildings where you have a concrete or GP water tank on top of it. So that the load of that water is considered as an additional load on the slab. So you have to make that calculation and apply the load on the slab. Okay, I'm going to explain this in the coming videos. We also have the point load, the line load, and the area load. Okay, we have the pattern load definitions, load decombination by finite elements. Finite element, or FE, is simply a method of analysis that we use both manually and that ProtaStructure also uses as well. Now, if your structure is going to be subjected to varying temperatures at different points in time, let's assume that you are designing this structure in Europe, where you're going to be having varied temperatures, degrees, very high, low temperatures, or so. You actually have to take that into consideration as well. Okay, so we go over to the review tab here. This is where you can actually check your building model. After you have successfully modeled the structure, you actually check it to see if there's any errors in the modeling. Okay, sometimes you can have overlapping slabs or overlapping beams or overlapping columns or something like that. So if there's any error in the modeling, it is going to show. So you have to come back and correct it. Okay, so you can also relabel your members. Okay, your columns are labeled as C1, C2, C3. Your beams are labeled as B1, B2, B3. So you can actually relabel your members based on your choice. You can move members to axis, you can delete axis, you can do all these as well. Okay, so under analysis, okay, this is where you now come to analyze a building after you have successfully modeled it and successfully. So you come here to run your analysis of the building. Okay, before you run your analysis, there are some parameters you have to set. This is what I'm going to explain even before we get to this point, because there are some basics that you have to understand to be able to carry out your design properly. Like you have to understand what concrete grade means, what steel grade means, what diameter of bars that we use for structural elements, like the diameter of bars that is recommended for columns, for beams, for slabs, okay, for foundations, different diameter of reinforcement bars. Okay, so we also have finite element floor analysis. Like I said earlier, finite element analysis model is a model of analysis of structural members. So ProtaStructures uses that model to analyze its buildings. Now this is a raft. Okay, so when you have a raft foundation, okay, you can actually use this tool here to design your raft foundation. You can update or delete tables, axial load comparison report. This is where you get to see all the axial loads on the building. Of course, the axial load on the columns of the building. Okay, so you have your design here. After you have successfully done your analysis, the next thing is actually to make your design. Okay, to make your design, that is to see the reinforcements, the types of reinforcement, the spacing of the reinforcement, and other information. So you can actually see the reinforcement of the columns, of the beams, of the ribbed beams, that is if you have a ribbed slab, and then of the foundation beams, that is if you have maybe a kind of strip foundation, or you have a raft foundation. This is where you actually get to see the foundation beams. Okay, so you get to see the slab analysis and design. This is the tools that you use to analyze and design the slab. This is for roof slab. This is for pad foundation. This is for your pile foundation. That is your pile cap that will be resting on the piles itself. Okay, so you can actually use ProtaStructures to design pad, raft, and pile foundation. You can also use it to design strip foundations. Okay, so column punching check. This is actually a check that we carry out for columns. That's what we call column punching. Okay, so I'm going to explain what that means in the coming videos. So you can actually see which of the deflection of the beams, the deflection of your slab and of your roof slab. This is steel columns, the I section columns, the I beams column, the bracing, the purlines. It gets the trusses and your frames. Okay, so we'll talk about all this in the coming videos. Now, if you go to reports and drawings, this is actually where you can detail your drawings. Okay, there is a tool called ProtaDetails. This is another software, like I said in the beginning of this video, that is installed together with ProtaStructure. So this ProtaDetails is actually a software that helps us do our detailing properly. Okay, so we actually import our drawings to ProtaDetails, and then we can export it to AutoCAD if we want to print out from AutoCAD. Okay, so that is where we go to do our detailing of the form plans, that is the floor plans, the columns, application and elevation plans, the story beam elevation, and all this and all this. So ProtaSteel is another software that is for steel design, so we'll talk about that also. So you can actually see the quantity extraction tables. This helps you actually estimate the concrete volume that will be used in the structure. So if you know the concrete volume, you can be able to calculate the number of bags of cement, the trips of sand, the trips of granite or stone aggregate that will be used in the structure. So this gives you a very approximate idea of the quantity of materials or the bill of quantities that should be used in the building structure. It's not very detailed, but it gives you an approximate idea of the bill of quantities. Okay, so you can actually use this tool to estimate the quantity of reinforcements that will be in the building, in the beams, the columns, the slabs, the foundation, and everything. Okay, so you have your report manager. You can actually generate a report after you have done everything. Now you have your BIM. Also, all the tools that we have in building set out are almost here. You can import your drawings from AutoCAD and to ProtaStructures, or from Revit to ProtaStructures. Now there are other softwares that actually collaborate with ProtaStructures. You have SAP. SAP is another structural design software. Okay, but it's mostly used in Asian countries because it is very efficient for earthquake analysis and design. The same thing with ETABS. ETABS is also a very good software for structural analysis and design, especially when it comes to seismic analysis or earthquake analysis. Okay, so we have a display. This is where you can actually see some things on that display. You have your view, how you want your interface to look like. and then you can see the help area. Now, if you look at this left hand area, you have your tree view. This is what we call the tree view. Under this place, anything you create in ProtaStructures is automatically shown here. Your beams, your columns, your shear walls, your slabs, rib slab strip, trusses, everything shows here. Now, this ST0 simply means the DPC level. Okay, ST01 simply means your first floor level. If you create more stories, it will be named as ST2, which is your second floor level, ST3, and so on and so forth. So under each story, we have all these structural elements. Okay, so as we create the structural elements, we can be able to see them right here. Okay, so you also have different stories or different views. If you want to see the 3D view, you just right click on views and click on this, and then click on physical 3D physical model, and the 3D view will be created. So this is just a brief introduction of the tools that we have in ProtaStructure. So in the next video, I'm going to be showing us how we can actually begin our modeling in ProtaStructures. Okay, so we are going to use the two methods in this training. We are going to model a structure in ProtaStructures, and then in another project we are going to import from AutoCAD. Okay, import from AutoCAD. That's what we're going to do. So we're going to be covering several projects in this tutorials, both building structures and non-building structures, and we're going to be using very much or many of the tools as much as possible in this tutorial, so that you can be able to understand how they work, so that when you get any project in the future, you'll be able to apply the same principles to your own personal project. So right here, we're going to stop for this particular video, and I'm going to see you in the next video.